Okay, I had a weird error. Sorry, guys. All right. Good afternoon, everybody. I'm Mike Pennington. I'm here to welcome you to the Project Development and Environment, also known as PD&E, introductory course for contamination for PD&E project managers and engineers, provided by the Florida Department of Transportation, FDOT, Office of Environmental Management, or OEM. This course is consistent with the information covered in Part 2, Chapter 20, the Contamination chapter of the PD&E Manual, while providing additional background information for you. I'm not seeing the slide. Mike, can you? The screen you're sharing, so I can go to the housekeeping
Screen
slide?
sharing, yes. And you're not seeing anything at this point?
We just see the Aptum background.
Oh, okay. Hold on a second. One second. Do you see it now?
We see a Word document.
Yeah, that's the Word document that has the agenda, the course agenda.
Oh, okay. Okay. I was going to do the housekeeping slide. That's what I was.
Got it. All right, let me move that.
All right. There we go. Thank you.
All right.
Sorry about that, everybody. So for housekeeping, this webinar is being recorded and will be posted to the FDOT website to allow others who wanted to attend but couldn't to participate at their convenience. During the webinar, if you have any questions, please feel free to post it in the question box, and our team will monitor questions as they come in and address them at that time or at the end of the webinar. Our presenters will periodically be asking you to answer quiz questions using Mentimeter. The website for that is menti.com, MENTI.com, and prompts and codes will be provided to you for each quiz question when we get to them. So now I'll pass it on to, you want to go to the next slide, Mike? Sorry. So this will show you the question box on the picture to the right, and then the Mentimeter website below if you guys want to load that up on a different screen so you're ready when the questions come up. But now I'll pass it on to Mike to start lesson 1. Mike and Laura.
Hi, I'm Laura Heron. I'm with Actum, based out of Tampa, Florida here, and we're going to talk about lesson 1, Contamination 101, which is back to basics for contamination. We're going to talk about contaminants, media, risks, and drivers. So let's go over some definitions of contamination and contaminant. So these definitions are found in the PD&E Manual, Part 2, Chapter 20. And the first definition is contaminated or contamination. And what this means is the presence of any contaminant in your environmental media, such as surface water, groundwater, soil, sediment, or upon the land. And you can find concentrations or the applicable cleanup target levels in Chapter 62.777, Florida Administrative Code, or FAC. Your water quality standards can be found in Chapters 62.302, 62.520, and 62.550 FAC. So what is a contaminant? Well, a contaminant is any physical, chemical, biological, or radiological substance present in any environmental media which may result in adverse effects to either your human health or the environment, or which creates an adverse nuisance, organoleptic, or aesthetic condition in groundwater. And what organoleptic means is basically your color, odor, taste, type of characteristics of groundwater. And what is a contaminated site? Well, a contaminated site is simply any site that these hazardous substances, pollutants, or contaminants that are harmful or likely will be harmful to human health or the environment. So let's talk about risk as it's associated with contamination. And risk has two variables. You have consequences and you have times probability. So what are consequences? Consequences are the severity of impacts due to contamination. Probability is just the likelihood that those impacts may occur. And there's several types of risk associated with contamination and contaminated sites. And they include human health risk and ecological risk. So there's various steps in a risk assessment that were developed by the United States Environmental Protection Agency, or EPA, and they're the following. First is hazard identification. The first step you have to do in a risk assessment is figure out what you have in the environment that's causing the issue. So you're going to figure out what type of contaminants you have that may be causing harm to humans and or ecological systems. And then the second step is the dose response assessment, which is going to look at the numerical relationship between the exposure and the effects of that exposure. And then you're going to do an exposure assessment, which examines what is known about the frequency of the contaminants, the timing, and the levels of contact that you as a human may have or as ecological receptors may have. Risk characterization examines how well the data can support your conclusions about the nature and extent of the risk from your exposure to contaminants. So let's further talk about what a conceptual site model is. So the EPA and the Florida Department of Environmental Protection, DEP or FDEP, developed a conceptual site model to show the different pathways for contaminants that will result in exposure to humans or environmental receptors. And exposure pathways may include the following: direct exposure to humans, usually between direct contact through skin, exposure to humans via groundwater, which can mean drinking groundwater, or exposure to groundwater via showering or irrigation, landscape activities if you have a well on your property. Exposure to humans via surface water, which could mean recreational use such as swimming, fishing, boating. And exposure to humans from contaminants in the air, you're breathing in the contaminants. And exposure to organisms or ecological risk. So let's look at an example conceptual site model. So here you see various different types of transport mechanisms that can affect you, that the contaminants can affect you through. So here we have direct exposure, and you can see there's a child playing with contaminated soil. Then you see we have a well, and the well is supplying water to the residents. And you can see they're either drinking it or being exposed to it in the bathroom through showering or taking a bath. Then you have discharge to aquatic habitats. You have groundwater with the potential to discharge to a stream, so your contaminated groundwater can affect your surface water bodies. Then you have vapor and dust emissions. Vapor and dust emissions can occur through disturbance of contaminated soil and or vapors that will enter the subfloor of residence or any type of building. And then you also have discharge to aquatic habitats and ecotoxicity. So let's talk about what cleanup target levels are for different contaminated media. And the DEP has developed cleanup target levels, or CTLs, for 3 primary media: soil, groundwater, and surface water. So soil cleanup target levels, or SCTLs, can be found in Chapter 62.777 of the Florida Administrative Code, or FAC. Groundwater cleanup target levels, or GCTLs, can also be found in the same chapter. And your freshwater and marine surface water cleanup target levels can be found in Chapter 62.777, 62.302, 62.520, and 62.550 of the Florida Administrative Code. And also the EPA and the DEP and the Occupational Safety and Health Administration, or OSHA, have developed different guidelines for concentrations of contaminants in the air that can be inhaled. And these are relevant for DOT projects in the form of asbestos and or lead contaminated particles. So let's look at some soil cleanup target levels. So soil cleanup target levels are calculated by the DEP and are provided for direct exposure residential, for direct exposure commercial or industrial, which means those contaminants that could be associated with the soil beneath a building or a factory or an industry. And then you have leachability of soil that can leach into various different types of water media, especially groundwater. So let's look at some soil cleanup target levels. So in general, the direct exposure, the residential soil cleanup target levels are lower than the commercial or industrial simply because you have different populations that could be affected by those type of contaminants, particularly the elderly and children because they live in residences. And then you have leachability based on groundwater. These concentrations also can be lower than direct exposure because the value is based on the assumption that the contaminated will be ingested via groundwater, meaning that you're using the groundwater as a potable water source. And then commercial and industrial direct exposure SCTLs are applicable to soils within the DOT right-of-way. So these are the SCTLs that you folks are going to be most concerned with. And there's different units for soil and groundwater. The units for soil are typically measured as parts per million or parts per billion. And parts per million is equivalent to milligrams per kilogram, and parts per billion is equivalent to micrograms per kilogram for soils. And then for groundwater, ppm or parts per million is equivalent to milligrams per liter, and ppb or parts per billion is equivalent to micrograms per liter. So let's look at a typical soil cleanup target level table that you'll find in chapter 62, 777. And these provide all different contaminants and their corresponding STLs. So you see in the left-hand column, you have a list of chemicals, and you have arsenic, benzo, benzoate pyrene, ethylbenzene, lead, toluene, total recoverable hydrocarbons, and xylenes. And most of these chemicals are associated with petroleum hydrocarbon contamination, with the exception of arsenic and lead. And then you see you have these asterisks here. Well, these asterisks pertain to the chemicals arsenic and lead because there's no leachability-based concentrations for groundwater. That means that these concentrations have to be derived. You have to run the synthetic precipitation leaching procedure, or SPLP, in order to obtain those values. And then you have the chemical abstract number, or the CAPS number, and this simply is a number that's been assigned for every chemical that's ever natural or man-made, and this will give you additional information about the physical attributes of that chemical. So let's look at groundwater and surface water cleanup target levels. And they're calculated by the DEP and are provided for the following types of waters: groundwater, fresh water, surface water criteria, marine surface water criteria. And you'll notice that the surface water criteria is broken up into freshwater and marine. So it depends on what type of water body that you're in, whether you're in a freshwater body or water body. And you also have groundwater for field. So here's another example of a typical groundwater cleanup target level table that you find in chapter 62, 777, which provides your GCTLs. And you see here that you also have asterisks, and you have the same chemicals that we saw in the previous table. And these asterisks mean that your benzoate pyrene values for freshwater and marine surface water have to be combined with other similar type of chemicals in the benzoate pyrene family. And then again, you have your chemical abstract number, or your CAPS number, and you have your freshwater and surface water criteria numbers that would be applicable to whatever type of water body you're in. And then you have your groundwater criteria. So let's go over some acronyms associated with contamination regulations that you should be familiar with. So first one, US EPA, United States Environmental Protection Agency. That's an easy one. Is the federal agency responsible for developing environmental regulations as well as enforcing them. the Florida Department of Environmental Protection, which has been delegated by the US EPA to ensure compliance and enforcement of environmental regulations, and also RCRA, which is your Resource Conservation and Recovery Act. These are federal regulations that pertain to solid and hazardous waste. CERCLA is your Comprehensive Environmental Response, Compensation and Liability Act. These are federal regulations that govern the cleanup of abandoned contaminated sites, and this is where you'll hear Superfund, or this is the Superfund law. And then you have HSWA, which is your Hazardous and Solid Waste Amendments that amended RCRA. SARA, which amended CERCLA, is your Superfund Amendment and Reauthorization Act. And then finally, NIPDES, which is your National Pollutant Discharge Elimination System. And these regulations pertain to stormwater and dewatering discharges. And one thing that everyone should keep in mind, that not only do you have NIPDES regulations on the federal and state level, but you can also have them on the county level. For example, here in Miami-Dade County, Code Chapter 24 also provides information about the specific county regulations for their NIPDES program. Now I'll turn it over to Mike Gonzalez.
Hi, everyone. I'm going to talk a little bit about the media affected by contamination on DOT projects. We'll start with soils. Those are most normally impacted by petroleum products, solvents, pesticides. See a lot of arsenic in Florida as well, and then also some metals. These are the recreating. Groundwater, most commonly impacted by petroleum products, pesticides, solvents. You have dry cleaning compounds as well. Bridges and other DOT-owned structures. This is where we're going to run into issues with asbestos and metal-based coatings. Surface water, this is normally only coming into effect if we're dewatering and we're discharging to a surface water body, but you need to worry about metals, petroleum compounds, also probably nutrients and turbidity. And other media, this is railroad ties, muck, rocks, buried debris, anything else that might be contaminated. When we look at the risks for the DOT roadway projects, there's really three primary ones. The first one is the exposure of the roadway workers to contamination and also the general public. Next is this increased liability to DOT if we cause or exacerbate that contamination. We'll talk a little bit about that later. And the third one really is for the handling and disposal of that contaminated material. You obviously want to be disposing of that material in the correct manner. There's some regulatory drivers related to these, this contamination issue. And the primary ones are Chapter 376 and Chapter 403 of the Florida statutes. And also there's some Florida administrative codes, 602 or 302, 550, 62701, those ones. But the primary issue really is in Chapter 376, which is the pollutant discharge prevention. And there is a section in there that says this: FDOT is not subject to liability imposed by these chapters for pre-existing soil or groundwater contamination solely due to its ownership. But there's a caveat. It says, however, liability may apply if FDOT creates or exacerbates a pollution source. That's kind of an important thing to know. There's some other regulations like Florida Administrative Codes 62730 and 62780, and then the other ones that Laura was mentioning, RCRA, HSWA, CERCLA, and SARA. All of those apply when we're looking at assessment, remediation, and disposal. A couple of things related to DOT's obligations to federal highway, especially when it comes to NEPA. There is a contamination impact requirement. DOT assumes federal highways' responsibilities for NEPA, especially for the state highway system and the local agency programs. Federal highway has the responsibility for anything with federal funding. But in 1998, they came up with an interim guidance that talked a little bit about the assessment of potentially contaminated sites for projects, especially in the project development process. In 1998, they came out with a policy revision that talked a little bit about brownfields, but brownfields we don't really run across too much in DOT projects. In 2003, Part 2, Chapter 20, which used to be Chapter 22 of the PD&E Manual, set out some guidance for the review of contamination for projects. And in 2014, there was a memorandum of understanding between FDEP and DOT as it relates to the contamination, and that we're going to talk a little bit about in lesson 5. Look at some practical reasons for the contamination review. Obviously, the first one is to prevent exposure to workers and the general public. You worry about exacerbation of existing contamination, especially during the construction activities that could cause liability to DOT. Other adverse impacts like costs, schedule delays, impacts to public health, all of those things kind of come into play, as well as a couple of other minor items. Well, maybe not minor. Public perception, obviously, is a big thing for us. Right-of-way acquisition. In some cases, you will have an issue where you may have to get additional right-of-way or do a construction easement if there's a right-of-way issue related to contamination. And then impacts to ongoing assessment and remediation for outside or third parties. We're going to do a quick quiz here. This is related to the DOT process, and we're going to go over to Mentimeter for that. And I think, Christina, I think you can take control of that.
Yep, I'm going to start sharing my screen. It's not letting me click to share my screen here. Aha, there we go. Okay. Let's see.
Yeah, I just had to make you organizer.
Aha, all right. All right, can you guys see my question 1 of 1 with a whole bunch of icons joining?
Yes.
There we go. Okay, awesome. Great. All right, we'll give people a couple minutes to join in. You can make a fake name or you can have a real name. The results will be posted at the end of our question here. So just as a note, when I hit the enter button to continue, you'll see a little timer countdown, and that's giving you enough time to read the question. And then you'll have 15 seconds in order to select your answer. And the faster you answer, the more points you get. So you don't just have to be correct, you got to be fast too.
Everybody note the code up at the top of the screen
Yeah.
that's being shared. You'll need to enter that on menti.com.
Yep. And it'll be different for each quiz that we do, but it'll still be on menti.com. So you'll just have to enter a different code each time here. So for each lesson, it'll be a different code. Some lessons will have 1 question, some lessons will have 2. This one just has 1. All right, I'm not seeing anybody else join. Oh, a couple more. All right, we'll go ahead and begin. So answer fast to get more points. FDOT is required to clean up all pre-existing contamination found in its right-of-way due solely to its ownership of that right-of-way. True or false? All right. That is false. So we had a few people answer true and a few people answer false. So let's see here who the winner is here. Shammy! Followed closely by Magical Rhino and John. Very nice job, guys. Nice job, Shammy. All right, so that's our first quiz. We're going to go through, like we mentioned, a series of these quizzes here. Some lessons have 1 question, some lessons have 2. So just keep that menti.com browser up and ready to go, and you'll be prepared for the next quiz. So I'm going to pass it over to, let's see here. Change presenter. Do I pass it back over to you, Mike Gonzalez?
Yes, please.
Okay. All right, here we go. All right, back to you.
Okay, let me know if you can see the screen. Oh, you need to go to share, screen sharing. Okay, can you see the screen now?
Yes.
Yes.
Okay, perfect. All right, thanks. Okay, yes, so I'm gonna have to click back. Or click back on the screen. 1 second. Sorry, technical difficulty. Yes, so the answer to that is false. DOT is not required to clean up contamination just because it's in the DOT right of way. So some other considerations for contamination projects. There's a contamination level of effort that increases as you go from PD&E through design to construction. There should be avoidance methods for during planning and PD&E. And the impacts need to be considered when you're looking at design modifications or when you're crafting special provisions, especially how you're handling and disposing of contaminated material. Contamination is normally addressed by the DOT PMs and the DCICs, but it could include right-of-way staff, design, construction, maintenance, and OGC. A couple of definitions and acronyms we probably should go through. First one is the DCIC. What is the DCIC? He is the primary person, he or she is the primary person responsible for addressing contamination issues in your district, usually out of the environmental office. Also, there's a contamination assessment and remediation, or CAR contractor. It's usually a vendor selected by DOT, typically by the DCIC, but not always, that performs the services for the hazardous and contaminated materials, as well as several others. The level 1, or CSER, Contamination Screening Evaluation Report, is an evaluation of potential contamination along all proposed project alternatives, and it's really used to determine the scope of further assessments. The level 2, also known as an Impacted Construction Assessment, or ICA or ICA, is the detailed evaluation of those sites and really is done for the medium and high rated sites. And you're looking for the extent of contamination and the type of contamination, and also determine any potential construction impacts, possibly even associated costs. That then leads to the level 3, which is the actual remediation or abatement of that contamination. There's usually a detailed plan for the removal and disposal of media and storage tanks or any other contamination that is needed. Some other frequently used acronyms. ACM, talk a little bit about that. Asbestos containing materials. This is any material that has more than 1% asbestos. Lead-based paint. This is paint or other surface coating that the lead would exceed the 0.5% by weight. There's also metal-based coatings, and these are coatings that can contain heavy metals, which include cadmium, arsenic, lead, zinc, and chromium that are present in concentrations that would be considered hazardous. A couple other ones to talk about. The MSP, this is the Modified Special Provision. This is a provision to address a specific project need and is usually approved by the state specification engineer. And then we have a technical special provision, which is the technical version of a special provision that you would need for any technical issue, such as a contamination remediation. And that should be included in the appendix for the contractor's information. And that's all we have for this first one. Please let me know if you have any questions.
All right, can you guys see my slide? Can everyone see my slide?
We're looking at your desktop.
Hmm. How about now?
Nothing yet. We're just looking at your video now.
Good times. Well, I also wanted to let folks know, we did try and plan a couple breaks for y'all today. Can you see the course agenda?
Nope, just seeing your video right now still. There it goes. Okay, now we can see it.
Okay.
All right.
All right, so on the course agenda, I'll be covering lesson 2. My name is Lauren Bowes with Atkins. I'm gonna try and get us to 2:10 so that we can have a quick 5-minute break and then come back for the next 2 lessons and then another 5-minute break. So just so y'all know, we will have some spots in here for you to get up and stretch your legs for a second before we get back started on the material. All right, so let's see if we can try this again. And can you now see my slide?
We can, yep.
Perfect. Okay, so this is lesson 2, contamination in the PD&E process. This second lesson is going to provide information on aspects of the project that should be considered to determine if there may be contamination involvement during the PD&E study. It also discusses how contamination is addressed in NEPA documentation as part of the early phases of the project. And it also helps describe the role of the DCIC and some of the project manager roles. The DCIC, again, is the key district level FDOT staff person that is knowledgeable regarding contamination issues and how they are best dealt with on DOT projects. The most common types of contaminants that affect FDOT roadway projects are petroleum-based products, metals in soil, asbestos, and metal-based coatings. So for petroleum products, there are 3 main types in the soil and groundwater: volatile organics, namely benzene, toluene, ethylbenzene, and xylenes, which are commonly referred to together as BTEX. Semi-volatile organics, most commonly benzoapyrene and related compounds, and total recoverable petroleum hydrocarbons, referred to as TPRH. And if you'll remember, you saw those in the tables in lesson 1. Asbestos and metal-based coatings found on bridges and in structures taken during right-of-way acquisition. Metals in soils. Arsenic is the most common, but lead and chromium can also be found in certain types of sites. While arsenic may be naturally occurring, it was also systematically applied as an herbicide at locations such as railroad lines, golf courses, and citrus groves. So some of the less common contaminants affecting FDOT roadway projects include solvents, PCBs, herbicides and pesticides, and landfill debris and other solid waste. All right. So the first one, solvents, include 3 primary categories, such as chlorinated volatile organics, dry cleaning solvents, and paint stripping compounds. Then you have the PCBs, or polychlorinated biphenyls, herbicides and pesticides, landfill debris and solid waste, and contaminants in soils leaching into groundwater. While some of these wastes may not technically meet the definition of contaminated or hazardous, the FDOT often uses a contractor to handle their removal and disposal. So here are some project considerations. We're going to run through several of these for your FDOT project during the PD&E phase or early in the project phase. Has an evaluation been done to identify potential sources of contamination that may overlap new right-of-way or project alternatives? So has somebody already looked at this? Are there impacts to design or are avoidance measures possible? Can we avoid the contaminated sites or do we need to account for them during the design? Do assessment and remediation costs need to be considered as part of the 5-year work program? Can impacts be addressed prior to construction, which is the hope, or will there be involvement during construction? Is extended possession of the contaminated properties needed, or can these sites be cleared prior to the start of construction? Will FDOT activities influence contamination due to dewatering, use of sheet pilings, or due to pond construction? Will groundwater testing to obtain an NPDES dewatering permit be needed? Have you determined all permits that are needed? Dewatering requirement considerations also include permits from FDEP, water management districts, and local agencies. So make sure to check them all. What is the status or remediation status of assessment or remediation on FDEP contamination sites? Part 2, Chapter 20 of the PD&E Manual provides a list of additional considerations on the project to determine their likelihood for contamination involvement. This is one of the first ones, and we'll go through a few more. The size and depth of soil and or groundwater plume, if it's already been documented. Is the contamination petroleum only, or are there other contaminants involved, such as metals, solvents, herbicides, etc.? Are there underground storage tanks, above ground storage tanks, or hydraulic lifts on the properties obtained as FDOT right-of-way? Are there structures such as bridges or utility pipes with potential asbestos-containing materials or metal-based coating concerns? Are there railroads present, including both active and former railroad lines? And what remediation or construction methods are necessary to prevent exacerbation of contamination potential due to dewatering, use of sheet pile, or pond construction? Determine if the pond is to be constructed with a liner. So those are all some considerations for contamination when you're reviewing your project. We're going to talk a little bit about how to do that, different sources of information that you can use to review the contamination potential. So reviewing the potential scope of contamination involvement involves steps in every phase of the project. The goal of contamination review is to identify contamination issues early so that they can be avoided or minimized. The level of investigation may increase as the project progresses, but only if it's warranted. The first part of the process is the ETDM screening and project scope development. The ETDM screening allows for early regulatory review of the project. The planning screen helps identify potential contaminated sites within or adjacent to the project, while the programming screen helps determine whether a level 1 investigation may be needed. The DCIC participates with other ETDM screening review staff to address comments made by the ETAT Environmental Technical Advisory Team. Coordination with the ETAT is continuous throughout the process. The DCIC especially reviews comments from ETAT related to contaminated sites. They will determine if there will be a need to place environmental infrastructure in the right-of-way per the 2018 MOU with FDEP. This includes evaluating potential for sites that may fall under the 2014 MOU between FDEP and FDOT. All right. During PD&E, a level 1 evaluation or contamination screening is performed to screen known and or potentially contaminated sites that may impact project alternatives. Each site is evaluated for impacts to each project alternative and is assigned a risk rating. We had mentioned that earlier in lesson 1. The scope of a contamination screening evaluation report, CSER, or some folks call it CSER, is developed by the DCIC in cooperation with the project manager. The level 1 evaluation is documented in the CSER with findings summarized in the appropriate environmental document. Projects with construction activities that can influence soil or groundwater contamination warrant more detailed evaluation. Determining high and medium ranked sites to be evaluated further as part of a level 2 investigation, and noting that further evaluation as commitments in the SEER or other environmental document. So this is an exercise to follow a methodology to relatively accurately estimate the number of hours needed to prepare a CSER. So these are for folks who are estimating hours during scope development or negotiations. The hours estimate needs to factor in the following considerations: the length of the project corridor, the complexity of the project, the setting, whether it's urban or rural, and the number of potential contamination sites along the corridor within the distances referred in Part 2, Chapter 20. The DCIC will also be calculating the hours as part of the hours negotiations. Note that the following example is just an example from one district, and that some districts estimate hours differently based on their preferences. So here we're going to get started with some formulas and an example exercise. This slide shows a formula for calculating the number of hours to perform the field work for a CSER. This is for a relatively simple project. The calculation of the mileage needs to include all mileage associated with any PD&E alternative alignment. And the basis of hours assumes the field work will be conducted by one person. If more than one person is needed for the site visit, the increased hours should be justified to the DCIC during negotiation. So here is your basic formula: 8 hours for setup, and then 8 hours for every 5 miles of project length, to a maximum of 24 hours for more than 10 miles. This slide shows a formula for calculating the number of hours to write the CSER. So before we were talking about fieldwork, this is actually creating the document. The hours estimated per site varies from as little as 1 to 4 hours, depending upon the potential complexity of the site and potential availability of documentation regarding the site. So this number can change from 1 to 4 hours for each potentially contaminated site, and 1 to 2 hours for each permitted contaminated site. So now we're going to go through a quick exercise on how to estimate hours for a CSER. In order to accurately do this, the ETDM EST physical contamination waste layers can be used to determine an approximate number of potentially contaminated sites. The consultant has access to essentially the same information by accessing the FDEP Map Direct website, which is an awesome website. If you guys haven't used that yet, a lot of good info on there. So since knowing the potential number of sites along a project is crucial to an accurate hours estimate, it's helpful to use the ETDM environmental screening tool, physical contamination waste layers map, to identify the sites. In the following example from Polk County, the roadway is currently a 2-lane road that is being widened from Martin Luther King Boulevard to State Road 17 in Winter Haven. The corridor includes a mix of residential and commercial areas, is 8 miles long, and only central alignments with additional right-of-way acquired on either side are being considered. So your alternatives are central, left, and right. It's 8 miles in length, mix of land use, and those are your alternatives. So here's an example, a map of that example project. It starts down here near Martin Luther King Boulevard and ends at State Road 17. This map shows the EST physical contamination waste screen for the northeastern portion of the State Road 544 project. So this is up near US 17. The red, purple, and light blue large circular symbols are petroleum storage tanks. So you can see some of those on here. The yellow diamond symbols are hazardous waste sites. The yellow triangles are biomedical waste sites, and the orange triangles are septic tank sites, which are not typically considered contamination sites that need to be reviewed as part of a CSER. After reviewing the TDM EST physical contamination waste layers screen for the entire length of the project, a total number of 32 potential contamination sites were identified. The 32 potential sites were multiplied by 3 for their moderate complexity and potential available documents. So that, remember, it ranged from 1 to 4, and this estimate chose 3. And that gives you a total of 96 hours. Since the project length was between 5 to 10 miles, the estimated field work hours were 24. Remember, it was a maximum of 24. 40 hours were allocated for the report, which is part of the formula, and added to the analysis hours, which yields 136 hours for the analysis and reporting. Then the total hours for the entire CSER effort are estimated at 160 hours. While this exercise provides a good ballpark estimate of the CSER hours, it is not used by all districts. The DCIC in each district should be consulted to determine if there are additional considerations and to approve the hours for specific projects. So this is just an example, and you can go through it with your DCIC per district as you guys are developing hours. Next is moving on to quizzes. So I will go ahead and let Christina get us back over to menti.com.
All righty. A little sneak peek of the questions there and the answer, or the options for your answers there. And I'm going to go ahead and start sharing my screen. Okay, can you guys see my question 1 of 2 slide there?
Yes.
Awesome. So this time we're going to have 2 questions. All right, see a couple more joining. All right, let's go ahead and get started. Remember to answer fast. What are the most common contaminants affecting FDOT roadway projects? All right, tricky one, huh? So the first answer here, petroleum products, diesel, gasoline, and oils. Second option, metals, primarily arsenic and lead. Our third option, asbestos and metal-based coatings on bridges. And our final answer of all of the above is indeed correct. Nice job. All right, let's go to the second question here, and we'll see who is in the lead. Question 2 of 2. The potential presence of USTS and ASTS in a right-of-way acquired by FDOT is an important consideration regarding contamination. True or false? Time's up. True. Potential presence of USTs and ASTs in a right-of-way acquired by the FDOT is an important consideration regarding contamination. Nice job. All right, let's see who won. Bodie McBoatface. Very nice. Followed closely by the Penguin and Chelsea. Nice job, you guys. Woohoo. All right, I am going to pass the presentation back over to Lauren.
Thank you. All right, can you guys see my presentation screen?
Yep.
Perfect. Thanks, Christina. All right, as Christina went through, the first one was a little bit tricky. It was all of the above. Based on the slides, we had it broken down into the most common contaminants and lesser common contaminants affecting DOT right-of-way projects and DOT roadway projects. So that was all of the above. And then for the second question, it was talking about the potential presence of underground storage tanks and above ground storage tanks being an important consideration, and that answer was true. All right, so now we're going to talk about some of the environmental documents during PD&E. Environmental documents are developed as part of the NEPA process and are required to contain contamination information. The contamination documents are used to support the following types of documents as part of the NEPA process. So remember, these are required. Type 1 and Type 2 categorical exclusions, or CEs, and non-major state actions. These are your different types of environmental documents, by the way. Environmental assessments and environmental impact statements, or EA and EIS, you'll hear that term a lot. State Environmental Impact Report is a SEER, and then reevaluations, which we will be talking about in a later lesson. For both Type 1 categorical exclusion and a non-major state action, or NMSA, contamination involvement is considered, and a brief summary is included in the appropriate checklists. Type 1 categorical exclusion checklists use form number 650-5012. Under Part 1, Chapter 2 of the FDOT PD&E Manual. Non-major state action checklist uses form number 650-5030 under Part 1, Chapter 10 of the FDOT PD&E Manual. For both types of projects, the Level 1 Evaluation Report, your CSER, or the Technical Memorandum, as well as any subsequent evaluation information, is included in the project file. The Level 1 report, technical memo, or contamination clearance letter, as well as any documentation of subsequent assessment as appropriate, should be uploaded in the Statewide Environmental Project Tracker, or SWEPT. So pretty much any supporting information regarding contamination will need to be included in SWEPT for the project. This slide shows a Type 1 categorical exclusion checklist form with the area indicated item 10 to include contamination. The contamination section is filled out and this form is provided in Part 1, Chapter 2 of the FDOT PD&E Manual. Projects which are Type 2 CEs or categorical exclusions may have involvement with contamination provided that the involvement is determined to not be significant. For the Type 2 CE, the CSER or technical memorandum, as well as documentation of subsequent evaluations as appropriate, should also be uploaded in SWEPT. Briefly summarize project involvement with contamination based on the Level 1 evaluation in the Type 2 categorical exclusion form 650-5011. The summary should at least answer the following questions. Are there any known or potentially contaminated sites within or near the project area? So this is all information that needs to be included in your summary for type 2. How did the project avoid or minimize impact to any known or potentially contaminated sites? And are there sites that require additional investigation or level 2 assessment? Note that a determination of significance for contamination involvement is rare and can generally be described or be resolved through application of the procedures described in Part 2, Chapter 20 of the PD&E Manual. The information in the Type 2 CE form for contamination is captured in Section D3 of the form, which is down here, if you guys can see my cursor. Attachments to support the D3 portion of the form are provided in the Type 2 CE support document, and the D3 section typically includes a summary of the findings of the CSER, as well as a table listing the contamination sites and their rankings. A table may also be provided for the pond sites and their rankings. All right, moving on to an EA and EIS. CSER findings are summarized in the environmental analysis section of the environmental assessment or environmental impact statement. So that's over here, your comments and coordination section. A summary table of impacts for each alternative should also be provided. The comments and coordination section of an EA or EIS should discuss and include letters from agencies expressing comments on the level 1 evaluation, and resolution of those comments shall be documented in this section. For an EA with a finding of no significant impact, or a FONSI, the document will include a statement indicating the effect of the project. If contaminated sites affect the preferred alternative, the impact should be discussed in the FEIS ROD, FEIS, or EA with a FONSI. These documents should also discuss the remediation and mitigation measures planned to eliminate or minimize the impacts of contamination. As with other NEPA documents, the appropriate documents need to be uploaded in SWEPT. SEERS should summarize, no, this is the last one, SEERS should summarize the results of the contamination screening evaluation in the environmental analysis section of the SEER form number 650-5043. The summary should answer the following questions. Are there known or potentially contaminated sites within or near the project area? How did the project avoid or minimize impact to any known or potentially contaminated sites? And are there sites that require additional investigation for a level 2 assessment? Provide recommendations to be included with any contamination-related commitments. And again, you would need to upload the CSER or technical memorandum as appropriate in SWEPT. Reevaluations, we're going to have a lesson on that, but we'll do a quick review here. Any change to contamination impacts during design after the approval of the environmental document must be reevaluated consistent with Part 1, Chapter 13 of the PD&E Manual. Design changes to the approved PD&E concept should be evaluated for potential contamination concerns. Construction advertisement reevaluation should reflect resolution of previously identified contamination issues. Updates to contamination status and anticipated or actual activities taken to resolve the contamination issues should be discussed in the reevaluation form number 650-5029, lots of forms. Resolution may include a description of how the issue will be handled, if it will be addressed just prior to construction or during. Status of the sites identified in the CSER with a medium or high risk rating must be updated with subsequent reevaluations. The final resolution on disposition and method of addressing the potentially contaminated sites during construction should be summarized in the reeval. So now we're going to move on to talking about the project manager interaction with the DCIC. During PD&E, the PD&E project manager, the PD&E engineer, and the consultant support staff will likely be involved in coordination with the DCIC. The DCIC's role in the project does not end in the PD&E phase. So the PD&E project managers and engineers should be aware of what the DCIC's roles are as the project progresses into design and construction. The DCIC also works with the design and construction project managers during those phases of the project. So the DCIC covers contamination from the beginning of the project in planning PD&E all the way through construction. Among other responsibilities, the DCIC's roles include developing and negotiating scopes of work for PD&E contamination studies, such as your Caesars, and design contamination studies for mainline and pond Caesars. We went through an example of some of those negotiations. Review projects with FDOT PMs and an ERC, design concepts in phase 1 through final plans. Review of Caesars and design-related contamination reports. And evaluating and addressing previously undiscovered contamination impacts, such as unreported spills, unregistered tanks, asbestos-containing materials, new spills, etc. Additional responsibilities of the DCIC, we're going to talk about those. While most of the relevant DCIC roles were listed in the previous slide, PD&E project managers, PD&E engineers, and consultant support staff, design project managers, and construction project managers should be aware that the DCIC responsibilities may also include management of the contamination assessment and remediation contractor, the CAR contractor that was mentioned in lesson 1, including a letter of authorization, scoping budgets, field inspections, and report reviews. Maintaining contamination documentation for work done in the district. Emergency response activities on FDOT right-of-ways or facilities when not performed by the responsible party or the FDEP Bureau of Emergency Response. As applicable, the responsibility for hazardous materials and petroleum compliance issues for district facilities and maintenance yards. So the DCIC covers quite a bit. All right, the types of NEPA documents that are developed during planning and PD&E phases are generally completed during those phases. However, reevaluations and some other types of NEPA documentation can continue to be developed during the design phase. The contamination review is also continued into the design phase. The potential for contamination impact should be considered during design, planned right-of-way acquisition, and development of project design features. Plans are reviewed and additional level 2 investigations take place to identify areas of contamination, including potential for ACMs and MBCs. In some cases, contamination involvement can be avoided with minor design changes. Coordination with FDEP should take place for sites involved in FDEP petroleum cleanup programs. So these are contamination items to review during the design phase. Keep talking about that. Planned right-of-way acquisitions should be evaluated for their potential contamination involvement. Also during design, potential pond sites, stormwater management facilities, SMFs, and floodplain compensation sites should be evaluated. Drainage features and drainage easements should be evaluated if there are potential contamination impacts to construction activities. So don't forget the drainage and those impacts. During design, project managers should coordinate with the DCIC to develop modified special provisions and technical special provisions for projects that may have contamination impacts, including those that involve remediation, solid waste removal, or dewatering permits. The contamination review then evolves further as the project enters the construction phase. So we've talked about planning and PD&E, then we talked about design, and now we're talking about construction. For projects with identified contamination issues, the project manager and DCIC or their representative should attend the pre-construction meeting and coordinate closely with the construction PM to ensure the contractor is fully aware of potential contamination involvement, any commitments, remediation activities, avoidance measures, or any further coordination or measures as needed. This may include coordination with the district's CAR contractor. The CAR contractor's activities are managed and funded through the DCIC's CAR contract. The DCIC typically funds remediation of contamination by obtaining funding through the work program and then implementing the funding using letters of authorization to the CAR contractor. The DCIC will coordinate with project managers, project management to maintain awareness of the project letting schedules and construction milestones. And the DCIC and PM should ensure contamination commitments made during the PD&E and design are properly completed. So this is part of the coordination of the contamination from beginning to end of the project and making sure that all commitments made are properly completed. The DCIC and construction PM or engineer need to coordinate regarding project milestones. Also during the construction phase, the DCIC supports the construction PM and engineer on contamination related matters and verifies completion of any level 3 activities. The DCIC is also responsible for informing FDEP of source removal reports and providing FDEP with any required documentation and to ensure map notes are properly included for the remaining contamination areas. The level 1, 2, and 3 process, the progress and purpose of the contamination evaluations and remediation. The level 1, 2, and 3 processes have been developed to identify contamination concerns early and minimize their overall impact to construction, resulting in safer and a less expensive project. That's it for lesson 2, and I am shockingly right on time for our 2:10 for a 5-minute break. So I will bring over the timer here. We will start back up with lesson 3 at 2:15 for Mike Gonzalez and Laura Heron from Aptum to go through right-of-way in PD&E. right, everybody, hopefully we are getting back to our desks and ready for lesson 3. Got about 15 more seconds if you guys are getting comfy. All right. Well, our next lesson is going to be talking about right-of-way in PD&E, so I will go ahead and stop sharing my screen and the course agenda and turn it over to Mike and Laura.
Okay, let me know if you can see the screen. Can you see it?
Not yet. I think I just made you presenter.
Okay, let me know
All
when you
right.
can see it.
A window got hidden.
Yeah, that happened.
I can see your video webcam, but not the screen yet. So you might need to share
All right.
screen.
So Laura, just below that is the share screen.
There we go.
Okay. So Mike Gonzalez again, this is lesson 3. This is the right-of-way considerations for PD&E. One second. Okay. So there's some considerations that we need to have for contamination when we're looking at the right-of-way. One of the first is, will the roadway widening involve corner clips at intersections? Will the roadway widening or the alternatives do partial takes or whole takes on a parcel? Will the right-of-way be needed for pond sites or pond access or stormwater easements? Will there be a whole take, partial take, or widening in front of any of the medium or high rated sites? And will future capacity or safety projects require additional right-of-way at that same location? If it's a partial take, consideration should be given to doing a whole take on that parcel rather than having multiple projects impact the same parcel. The DCIC is there to support the PD&E and design project managers. And he or she is the main point of contact for information to support the appraisals for those parcels. And also would help with the right-of-way and construction offices when they're looking at parcel acquisition, especially advanced acquisition, or if we're going to be doing anything with extended possession. Obviously, extended possession would not be the best option in a site where we're going to be doing remediation. So I'll do some quick asbestos and metal-based coating survey basics. First off is that asbestos is a mineral fiber and it adversely affects the lungs if inhaled. There is a procedure in the right-of-way manual for 575 000 that talks about ACM surveys and abatements. And ACM is governed by federal laws, including the NESHAP, which is the National Emission Standard for Hazardous Air Pollutants. And it's also regulated by OSHA, which is the Occupational Safety and Health Administration. And asbestos, as well as lead-based paint, were banned from most products, but not all products in the 1970s. So most buildings constructed after the 1980s likely do not contain asbestos or lead, but that doesn't mean that it's a guarantee. So the Environmental Protection Agency, or EPA, has delegated NESHAP to DEP, the Florida DEP. And for that program, there is a 10-day notification prior to the demolition or renovation of any structure, and that includes bridges. All demolition notifications are required, even if there's no asbestos present. And also there is a delegation that the DEP has done to some local regulatory agencies as well. When you look at ACM and metal-based coatings, really what you want to do is you want to be able to do them as early in the design process as possible, because the abatements for those could affect the project schedule and can be time consuming depending on what you're doing to the building or structure. And FDOT requires that the contractors that they hire assume that ACM and metal-based coatings are present in any buildings built prior to the 1980s. Therefore, an asbestos and metal-based coating survey should be done for those buildings or structures. And now I'm going to turn it over to Laura. She's going to take care of some of the asbestos issues.
Hello, and I'm going to talk about some more asbestos issues that you should be concerned with. So we're going to talk about structural components that may contain asbestos, things that you should look for when you're involved with a project that deals with structures or bridges or buildings. So they can be found, asbestos-containing materials, or ACM, can be found in roofing, flooring materials such as felts, insulation tiles, flashings, and mastics. And your mastics are your adhesives that adhere the flooring material to the subfloor. Windows and windows and walls, including drywall muds, joint compounds, caulking, plaster. Also on windows, you can see it in window glazing. Insulation, including pipes and wiring insulation, including electrical, commonly used in pipes, plumbing pipes. Undersink spray coatings, which you normally don't think of, is going to have asbestos-containing materials, but they have been used for that purpose. Acoustical ceiling tiles is another very common place where you find asbestos, as well as machinery, brakes, and bearing pads, such as on bridges. Your brake pads still contain asbestos in your cars and your vehicles. And Class 5 coatings and paints. And also sprayed on fireproofing. And lastly, concrete. So let's look at asbestos-containing concrete, because most people don't think that asbestos is contained in concrete, but it can be, and can be found in concrete. So a product called Transite was commonly used from the 1930s to 1980, and it contains up to 50% asbestos. And Transite was very, very commonly used for sidings, material that was used in sidings on buildings, residences, and structures. It was also used in corrugating roofing tiles, again, siding, as I talked about, roof gutters, wallboard insulation, and various piping. Its most common occurrence in the DOT project is old abandoned water lines. These include municipal as well as private water lines. And if you find these pipes, they must be removed. Crushing and leaving the pipe in place is a violation of safety protocols. Can't do that. Asbestos may also be found in other types of concrete, such as foundations, slabs, and structural supports, but Transite is the primary type of asbestos cement. So here's a picture that shows a typical floor tile or flooring that you'll sample for the presence of asbestos, and you will sample underneath the floor tile for the mastics, which are typically a brown or black or yellow color. And also with mechanical rooms with concrete, it has coatings. You can also have insulation, wire insulation, pipe insulation in mechanical rooms. Here's the example of machinery brake pads that you would be sampling for asbestos. So let's talk about some of the asbestos sampling methodology. So what would you use in order to determine if a material contains asbestos? So in order to do an asbestos survey, you have to be certified, you have to have a certification, you have to perform your survey under a licensed asbestos consultant or an LAC. And you also have to perform your abatements under an LAC, and you have properly trained personnel as well, certified personnel. So when you go to do an asbestos survey, you look at the building or look at the bridge and you figure out what are your homogeneous sampling areas or what are your HSAs. And typically these are areas that are suspected for ACM. So you look at a building and say, okay, I'm going to sample the roof, I'm going to sample the wall board, I'm going to sample the tile, and those would each be separate HSAs. And how would you sample? Well, basically you use what you can to get the material off the structure and into a sample bag. So you would use a chisel, a knife, or similar tool. I've used screwdrivers, I've used crowbars, I've used anything I can to get a sample. And typically you collect 3 samples per HSA. Sometimes you have to collect more samples, or the 3-5-7 rule that we follow, and it depends on how large of an area you are sampling from, or how large your HSA is. And then we take notes to describe the appearance. Is it color, the texture, where it's located, the friability? Can you crush it between your fingers? If not, it's not friable. If you can crush it between your fingers, then it is friable. The condition, is it in good shape? Is it in bad shape, poor shape? And the quantity. Usually you'll define it in square feet or linear feet. And this is important for your abatement because you want to know the quantities that you need to abate. And then we take photos of each HSA as documentation. And then the samples are transferred using a chain of custody to the lab for analysis. So here are some examples of folks, a person collecting samples for asbestos. The one on the left, he's sampling the interior stucco finish, which can also contain asbestos. And a lot of times you'll sample ceiling finishes as well, such as popcorn ceilings. And then again, on the right, he's sampling an exterior stucco finish. And then here on the left, he's sampling exterior caulking that's around the window panes. And then to the right is just showing an area that was being sampled for exterior sealant. So let's talk about analysis used to determine the asbestos content of the materials. So your asbestos samples are going to be sent to a laboratory that's certified by the National Voluntary Laboratory Accreditation Program for analysis. And there's really 2 different types of analysis that are used when determining asbestos. The first is PLM, or polarized light microscopy, and this is an estimate that they use in a percentage of asbestos-containing minerals in a sample. And a sample is considered to have ACM if it contains more than 1% asbestos fibers. And when a PLM sample contains less than 10% asbestos fibers, you can use a more accurate method called the EPA point count method. And really you use this method when you have a substance that's suspect for asbestos, but it comes back negative, but you really, really think that it is, and so you would run an EPA point count method. Or if you have a substance that came back with a percentage of asbestos of maybe like more than, just a tinge more than 1%, like 1.5 or 1.2, you want to run a PCM method. And this involves viewing a thin section of a sample, and you actually count the presence of asbestos fibers at 400 equally spaced points in a microscope's view field. It's a pretty tedious process, but it's highly accurate. And because of that, your point count method will supersede the PLM results. So let's talk about the contents of an asbestos survey report. So say you had someone go out and do an asbestos survey, and you have a report in front of you, and you need to know what should be contained in that report in order for you to accurately determine what materials contain asbestos. So the report should contain the methodology, what they use to survey and sample the asbestos or the suspect ACM, the findings, photographs, the certifications of the surveyor and the consultant, and the laboratory data sheets or the laboratory results. It should describe which materials are ACM, which materials that came back greater than 1%, or if they did the point count method. And they're going to provide recommendations for abatement of any ACM areas. But sometimes the ACM needs to stay in place. And in that case, the consultant may provide an operations and maintenance plan for any ACM that is not going to be removed. And also some consultants provide cost estimates for abatement and O&M activities, and that's where the square footage or the linear footage of the material being sampled for that came back positive for ACM is used. That's how they base their cost estimate for removal of that material. And then it discusses any material that may contain asbestos that couldn't be accessed during the asbestos survey. And this is important because a lot of times, especially on bridges, there's certain areas such as bearing pads that can't be accessed, so you may presume it to contain asbestos. And asbestos abatement activities are considered level 3 activities. So let's look at a typical table of asbestos sampling reports that you should find in your survey report. So here you have on the left-hand side your homogeneous sample areas, or your HSA. So you see they identified 4 of them. And then you see your sample numbers corresponding to that HSA and the material description, and then the approximate quantity, and then your lab result. And you see that out of the 4 HSAs, only 1 HSA came back positive for asbestos, which is your chrysotile, came back 2%. They also did a point count, came back 2.3% on various different samples. They took sample 7, 8, and 9. And you can see the results and the column under lab results, and then the niche category. So they determined that this gray and white moisture barrier underneath the sink that was in the electrical room in the tender house was non-friable. So some references that you can use for asbestos surveys and abatement, you can use the DOT right-of-way procedures manual. 575-000-000 can be found in section 10.7 under asbestos management. Also, the United States Code, Title 29 CFR, Parts 1910 and 1926 for the U.S. Department of Labor, or the OSHA standards. And also in 40 CFR, Part 61, Section 61.145. That's the standard for demolition and renovation. Those are your EPA NESHAP asbestos regulations. And also your FDOT standard plans for road and bridge construction. So let's flip and talk about metal-based coatings, or MBCs, which are commonly referred to as lead-based paints. So MBCs must be surveyed for any painted surfaces that are going to be refurbished, stripped, or otherwise removed. And lead is the most commonly expected paint constituent that causes your paint material to be hazardous. Other metals that you can find include arsenic, cadmium, chromium, mercury, and these are metals that were commonly used in paints. EPA 40 CFR 461.2 provides the concentrations of these metals that cause the paint weight to be considered hazardous, or if these concentrations are exceeded. OSHA regulations 29 CFR 1926.62 addresses worker exposure to lead and protection of the workers from airborne concentrations of lead. You also need to protect your workers and environment from airborne metals. And you also need to protect your workers if they're doing any type of cutting, sanding, or grinding on painted surfaces that are suspect to contain lead or the above mentioned metals in the paint. So the presence of any of these metals require worker protection. We already talked about that, but the paint waste is tested using the T-clip, which is the toxicity characteristic leaching procedure. And you can do the T-clip for these different metals, and these different metals have different regulatory levels. For instance, lead has a regulatory level of 5 milligrams per kilogram. So if you exceed that in your paint chip sample analysis, then you're hazardous for lead, and it has to be disposed of and handled as hazardous waste. So let's look at some metal-based coating surveys, methods, analysis, and reports. So your paint chips, you collect them using various bladed tools. I know I collected them using a X-Acto knife or a box cutter. I've used scraping, a paint scraper, and sometimes the surface is so bladed with paint you can actually peel off the paint chips from the surface. And the chip samples are submitted to the lab for analysis, usually by EPA method 6010, which are total metals, or method 7471 for metals including mercury. And then you can also do an alternate method, which is a quick and easy method to determine if you have lead in your paints. And this is using an XRF fluorescence XRF analyzer gun to directly measure lead content in milligrams per centimeters cubed. However, sometimes even if the XRF is used, you want to take chip samples to submit them for to the laboratory for backup, just to confirm your results. And also think about multiple paint coating layers may be present. So when you go and you look at a structure and it's an older structure, there can be various different paints that were used. So you really have to make sure that you grab all the paint layers in order to obtain an accurate sample. And it's hard to separate them out, but it can be done. So let's look at some further survey methods, analysis, and reports. So analysis by total metals and T-clip may be used initially, but these analyses will also be used by disposal facilities to determine waste disposal. Again, use T-clip to determine how much or what the presence of the metal, the concentration of the metal is in the paint chip that you're collecting. And if it exceeds the T-clip regulatory level, and those can be found in the CFR as well, then you have to handle the material as hazardous waste. The survey report also includes recommendations to protect workers from airborne metal concentrations when they're doing any type of work on the substrate that contains that material. And also the report indicates whether the paint waste will likely exceed T-clip results. So let's look at some examples where you could find metal-based coatings on different type of structures or objects. So here's a paint coating on a steel mounting plate. Here's blue coating or paint coating on a bascule limit switch. And here's an example of an XRF lead concentration analyzer gun. Then here's a result on the XRF gun reading 1.1 milligrams per centimeter squared. And here's a typical table that you'll find in a metal-based coating surveys report regarding the samples that were collected, where they were collected, and the results. So you can see you had various different readings. This is actually an XRF result table, and you have various different locations. The color was all the same, yellow. The condition was peeling. One, it was intact. The peeling was noted mostly on the concrete, and you have your lead results in the right-hand column. So 10 of the 44 samples tested contain lead at or above 1 milligram per centimeter squared. The other contaminants that you need to be aware of in right-of-way buildings are polychlorinated biphenyls, PCBs. These are commonly found in electrical transformer oils, heating oils from home heating systems, hydraulic oils and lift systems at automotive facilities, also in elevator shafts, structures that have elevators, and also petroleum products stored in various businesses. And I will turn it over to Christina for the quiz.
All right, let's do a quiz. All right, can everybody see my question 1 of 1?
Yes.
All right. A few more seconds here. All right, let's go ahead and get started. So menti.com, oh, hold on. Yeah, that's right. Okay. We did enter the code already. Asbestos and MBC surveys should be performed as late as possible in the design process in case the plans to demolish a building are canceled. True or false? False. That is correct. Nice job, everyone. All right, and I think we only have one question for this presentation. Millie. Oh, we have a tie technically, but perhaps Millie answered. Oh, well, Joanna has fastest under hers too. So congratulations to both of you guys. Yep, it's a tie. Nice job, everyone. All right, I'm gonna pass it back over. All right, we can see your screen. That's perfect.
Okay, so we know this is false. It needs to be performed as early as possible in the design process. Thank you very much. If you have any questions, be happy to answer them.
Next up is lesson 4 with Christina.
All right, let me see if I can switch over my screen here.
We are running a little bit early, so you've got some time if you need it.
Awesome, that's great. Okay, going from Mentimeter to my presentation here. Let me pull it up.
We're scheduled to have a break around.
Around when, Laura?
Sorry, it cut off. Around 3:30 is our next break.
You cut off, sorry.
I was having a little bit of difficulty hearing
Still
you
there,
there,
Lauren?
Christina. Yeah, I can hear you. Can you hear me?
Okay, great. Yeah, now I can hear you. Yeah. Okay, that was on.
Okay.
All right, let me
No
start
worries.
sharing my screen here.
I was saying our next break is at 3:30.
Okay. Okay, there we go. All right, can you guys see now?
Yep, we can see your slide.
Awesome. All right. So this fourth lesson provides information on how a level 1 investigation is performed. Not only is detailed information provided on how the desktop review is performed, but additional information is also provided regarding how the site reconnaissance is performed and how interviews are conducted. It also defines how the risk ratings for each site are determined and assigned. So as shown on the slide, the level 1 evaluation is performed to screen potentially contaminated sites and determine potential contamination risk on each project alternative. If sites are identified during the level 1 evaluation that are rated medium or high, those sites are then further considered for a level 2 evaluation. The evaluation is for all roadway alignment alternatives developed during the PD&E. And the evaluation is for all roadway alignment alternatives. The level 1 evaluations are often performed by the consultants, but they may also be performed in-house by the FDOT staff or by the car contractor. So it should be noted that a CSER is generally prepared for all projects that have a PD&E study, and a simpler level 1 evaluation report or tech memo may be prepared for projects that do not have a PD&E study. And finally, the level 1 may need to be updated based on any alternatives added during the design. So a large amount of information can be obtained during the desktop review so that you can minimize the time needed for a field review, and the time for interviews can be limited to only those necessary to get information not already available from that desktop review. The desktop review can be divided into 2 main categories: your land use review and your regulatory review. So your review of land uses along a project are typically available during the early phases of the PD&E study. They're also provided in the county property appraiser files. The review of historical aerial photographs, this typical practice is usually to obtain at least 1 per decade going back to about the 1940s or so, and those are available from a variety of different websites. So you have your USGS topographic maps that are available online, your USDA soil maps that are also available online, where there's a useful natural resource conservation service tool that allows users to draw their own soil map of a given area, which is pretty cool. Sanborn fire insurance maps, if available. They normally only are available for developed areas. And of course, city directories and registries. In Florida, the most commonly available directories are the Polk City directories and the Hill Donnelly cross-reference directories. So experience working on desktop reviews has identified that of the sources available, the following are most useful for land use review. You have historical aerial photos from the 1940s to the 1990s. These potentially show now covered landfill sites, other disturbed areas, former gas station sites that have been redeveloped, things like that. We also use city directories from the 1940s to the 1990s. This may list former gas stations, dry cleaners, and other businesses of concern that may have been redeveloped with a different business. Of course, also mentioned earlier, the Sanborn maps in downtown areas of urbanized counties such as Pinellas, Hillsborough, Orange, Broward, Duval, Miami-Dade, etc. And of course, reviewing ground level photography on Google Earth Street View. Google Earth also provides aerial photos going back to the 1990s. I've seen it actually earlier, just depending on the area. So you can check out Google Earth Street View and use that little time lapse button and scroll on back. It's pretty neat to see the development. So historical aerial photos are used to review land uses along a project over a period of time. Here in Florida, aerial photography is usually available in most areas dating back to at least the 1940s and sometimes further back. It's helpful to review aerial photography for at least 1 year per decade. Historical photos from the 1940s to the 1990s are especially useful for showing potentially now covered landfill sites and other disturbed areas, former gas station sites that have been redeveloped, etc. Aerial photos may help identify landfilling or other earth disturbance activities, historical non-regulated gas stations, past agricultural uses, trucking facilities, possible cattle dip vats, heavy industrial uses, and other types of historical land uses. Historical aerial photographs are available from commercial vendors such as EDR, the USGS, FDOT, and of course your county websites. USGS topographic maps and the USDA soil maps may also show suspected contamination-related features such as areas of fill or structures and landfilling areas. The city directories are a really good source of information that could be used to correlate the businesses that formerly occupied a certain address with the current occupant of the site. It should be noted that sometimes how the addresses are numbered has kind of changed over time. So a reviewer of city directories must be aware of this. City directories are available from database vendors for a fee, or they can also be reviewed for no cost at your actual local library and going out there to check it out physically. Sanborn maps. So these are also available from database vendors and at libraries. They were originally developed in the late 1800s, and they were mainly used for determining fire insurance rates. In urban areas and more densely populated counties like Hillsborough and Miami-Dade, these Sanborn maps may provide the best information available for those areas prior to the 1950s. The city directories and Sanborn maps can provide information on occupants and services provided at an address that have since changed and may no longer be obvious as a prior use. For example, the city directory confirms that the property of interest State Department of Military Affairs has been present at this location in St. Augustine for many years. The Sanborn map from 1930 show the property in the northwest corner of the map as the office and auditorium of the Department of Military Affairs. So the purpose of the desktop review is to identify potential contaminated sites and to evaluate the potential for encountering contamination from current or prior land uses. So the review includes regulatory records, like we've mentioned, that are now typically available online. Your sources of data for desktop review are the Environmental Screening Tool, or EST, publicly available databases, databases from commercial environmental data service companies, databases maintained by the federal, state, or local governments or the regulatory agencies are the most reliable sources of data for the desktop regulatory review. So let's talk about some search distances. So we have various search distances that are used for the desktop review, and they vary based on the context of the project and the type of contamination source. So the recommended distance for searching is 500 feet from the right-of-way for petroleum, dry cleaners, and other non-petroleum sites. 1,000 feet for non-landfill solid waste sites and brownfields. And then even wider search of 1/2 mile for your CERCLA sites, your national priorities list sites, and landfills. Those sites are typically large and can extend long distances from the address locations identified in the databases. So that's why we have these varying search buffers for each of these different types of contamination sources. So a review of regulatory databases includes mapped potential contamination sites from the ETDM contamination screen and from commercial database vendors like we've mentioned, such as EDR, EDM, URIS, etc. From FDEP Oculus, the FDEP contamination locator map, which is really pretty cool, or local agency websites. Regulatory databases include permits and any site reports, with recent reports having priority. Experience working on desktop reviews has identified that of the regulatory databases available, the following are most useful. The Federal National Priorities List, or NPL, the Resource Conservation and Recovery Act, or RCRA, CERCLA, and the EARNS databases. While the state database sources are usually the most useful information, federal databases such as the Superfund website and EPA EnviroMapper may also be useful. The state or FDEP databases that are most useful are the Tanks and Leaking UST, Solid Waste Facilities, Brownfields, Waste Cleanup, Dry Cleaners List, and of course the Institutional Controls Registry, or ICR. Experience has shown that the following regulatory resources tend to be the most useful during the desktop review. The regulatory database sites developed from the EST or ETDM contamination screen or a commercial vendor database. File review in FDEP Oculus system using the storage tank, hazardous waste, waste cleanup, discovery compliance, permitting authorization, etc. Using the FDEP Map Direct, Institutional Control Registry, and Contamination Locator Map to identify active petroleum and non-petroleum cleanup sites. And in addition, the list of cattle dip VAT sites for rural or formerly rural areas can be found in the FDEP and University of Florida websites. Well construction and installation and abandonment permit information are also maintained by the water management districts for water wells drilled in those districts as well. Additional research should also be performed to determine if there are any available other sources available at FDOT. You can review in-house FDOT data such as previous right-of-way maps or as-built for the presence of map notes, which are the result of the FDEP FDOT MOU. asbestos piping that was taken out of service but not removed for access issues during construction. That might also be identified in right-of-way maps or as-builts from previous FPIDs. And of course, the PD&E and designers should work closely with the DCIC to determine if any previous evaluations or testing has been performed, and if that's still relevant for the project. So once sites are identified using screening databases, the actual records, such as monitoring reports and inspection reports, can then be reviewed. In Florida, the most useful database is FDEP's Oculus database, especially if the facility's ID number is known. The Oculus database contains a series of catalogs depending on the land use of a site of interest, such as storage tanks, hazardous waste, solid waste, etc. And each site typically includes a number of profiles, such as the cleanup and remediation or discovery and compliance, which those contain relevant reports. The FDEP main website provides general information about each program. Other FDEP data sources, such as the Contamination Locator Map or Institutional Controls Registry, Map Direct, and of course the STCM database. Those are all linked directly to the Oculus database. That's pretty nifty. So we're going to have two exercises in reviewing regulatory data from easily accessible online databases here in Florida. The first we're going to go over is the FDEP Contamination Locator Map. And the second we'll go over is the FDOT's ETDM. This slide shows a map of a roadway project and pond sites in Citrus County with the listed regulatory sites shown in red, yellow, and green symbols there in the legend. This type of database report is typically provided in a CSER, but it might be months or even more than a year old by the time the CSER is actually reviewed and approved. The first exercise we're going to do is going to determine if there are any open discharge sites currently along the project. So we've pulled up the FDEP Contamination Locator Map for the project area, and we've noted that there are several green triangles and 2 yellow triangles located along the project. So the green triangles represent open discharge sites that are in the FDEP Petroleum Cleanup Program. Sites with a yellow triangle indicate a site with an open discharge that are in the Waste Cleanup Program. Having an open discharge means that the site has not obtained regulatory closure, and therefore the site is likely in a groundwater monitoring program or is actively being remediated. So note that only a few sites in the in the EDM map here from the previous slide have open discharges. Open sites may also be newly discovered sites, new releases, or sites that are still under investigation. They also might be sites that are in the assessment phase. So clicking on one of these green triangle sites identifies it as St. Peter's Shell, located at 704 West Main Street. And this screen also allows you to click on a documents link that links to the latest documents in the FDEP Oculus file system, like I mentioned earlier. Clicking on the documents link shows that the site is undergoing remedial action, and the contractor for that site has recently submitted a remedial action interim report, which was reviewed by FDEP. Clicking on that red triangle on the right side of the screen allows you to review the FDEP warning letter, the review documents, and reports submitted during regarding the site. Information in Oculus often goes back to the 1990s because many of the older files were actually scanned and uploaded to the Oculus system after the Oculus system became fully operational around 2004. Finding more information on contaminated sites in the ETDM EST is easiest by going into the maps and then view interactive maps on the left-hand side of the screen. So once in the EST map viewer, you can go to the search layers and then the browse section. After clicking on browse, you would go to the physical, then the contamination, then waste layers, and indicate add all to map. That will appear on the lower right-hand side there. So reviewing that same general area of Inverness in Citrus County that was shown on the maps in the previous slide, we can see that there are many more sites in the FDEP's contamination locator map. And that's because the ETVM EST allows for a review of sites that are open discharge sites and those that have received regulatory closure. For example, many of the sites shown with red circles are petroleum sites that either have not had discharges or have received regulatory closure. The site with the large purple circle is the St. Peter shell that we were mentioning earlier, and the sites with the purple stars indicate that contamination was reported as migrating off-site from those sites. And sites with the yellow diamonds, as discussed previously, are the RCRA small quantity generator sites. The hanger symbol indicates an FDEP dry cleaner site. And the yellow triangle symbols and the orange triangle symbols are generally ignored as they represent biomedical waste and septic tank sites respectively. And those type of sites generally don't have any contamination concerns for roadway projects. For this review exercise, we're going to determine if there are any recent FDEP Oculus file information for one of the petroleum sites noted with a blue circle there. So clicking on that blue circle symbol reveals that the facility is known as quality number 188, and it had a petroleum discharge in 2005. The discharge was ineligible for FDEP cleanup assistance, but the site received no further action. Scrolling further down on the linked information allows access to that Oculus file like I mentioned earlier. So after scrolling down the information link, the reviewer can then click on the More Info link for the document L. And that document L links to the FDEP Oculus, or they can click on More Info by Google Map, which then links them to the site image on Google Map. Clicking on the More Info link allows the user to have access to the same type of screen linked by the FDEP Contamination Locator Map, except this is for any petroleum site, regardless of its regulatory closure status. Because the quality number 188 is an active gas station, the Oculus files indicate a number of records relating to the most recent inspections of the facility. In the case of this site, there was a limited closure assessment performed in January 2019. The most recent storage tank compliant inspection occurred on September 9th, 2020. And as before, clicking on that red triangle on the right side, any of those red triangles there allows review of the inspection documents and closure forms. All right, quiz time. So let's see here. Let me go ahead and exit out of this, and I will go ahead and bring up our quiz. So if you guys can go to menti.com. Give it a couple more seconds here. All right, I think we're ready to go. Let's start that countdown. Remember to answer fast. A level 1 desktop review would likely include the following elements. All right, nice job. Review of historical aerial photos, land uses, and regulatory files. Very nice. It would not include soil borings and groundwater sampling with laboratory analysis, and it would not include removal of USTs and disposal of contaminated soil. Nice job. We do have another question for this lesson, but it's not until further down the line. So we're going to go ahead and minimize Mentimeter. Don't exit out of your browser. Just go ahead and minimize it to keep in that same question. All right, so moving along here, we'll figure out who the winner is after that second question. So don't be alarmed yet. You'll find out if you won. All right, so once the desktop review is largely complete, the information provided in that review is then supplemented by information from a field review and interviews. The field review may contain information on additional sites that were not identified during the desktop review. So your typical sites of concern include gas stations and obvious former gas stations, dry cleaners, other hazardous waste handlers, auto garages, etc., railroad lines, NPL, Superfund sites, junkyards, scrapyards, things like that. Sites can be observed from the right-of-way, from public property available as access allows, or they can be accessed using a property access letter. Observation should also include searching for mounds or depressions, sinkholes, surface draining, distressed vegetation, suspicious odors, drums or other chemical containers. So while active gas stations such as the Shell station shown on the right are really obvious petroleum storage facilities, former gas station sites like this Panera restaurant, which is not far from the Shell, can be occupied by almost any type of business. So former gas station sites, it's important to search for cuts in the concrete, for signs of a former tank farm or monitoring wells, things of that nature. Citrus groves are frequently identified as potential contamination sites also. Although herbicides and pesticides are normally spread throughout the site per manufacturer's instructions, there can be significant contamination in areas where the herbicides and pesticides are mixed with water. Large spills might also happen. Also, many citrus groves have diesel-powered pumps for irrigation, with petroleum ASTs ranging in size from 550 to 1,000 gallons. Those definitely present potential petroleum releases. Shown on the right-hand side of the slide here is an auto repair facility at a former gas station, and both the current and former operations have potential contamination, such as solvents from current use and petroleum from past use. So railroad right-of-way are also known as potential contamination sources due to the arsenic, which is used as an herbicide, and due to the polynuclear aromatic hydrocarbons, or PAHs, in the treated crossties. The photo to the right shows a fuel UST that supports a cable utility, and the diesel UST feeds an emergency backup generator that helps the utility continue to operate. So most large FDOT projects require construction of some type of stormwater management facility, such as this pond along the east side of I-75 in Lee County here. Potential stormwater management facility locations must be elevated as part of the desktop, must be evaluated as part of the desktop review to determine any potential contamination that could affect construction of the stormwater management facility. So those must always be evaluated. Electrical transformer substations also present potential for contamination due to the PCB containing transformers. Nearly all these utilities have removed the PCB transformers, but remnants still may exist. A leak of petroleum dielectric fluids from newer transformers may also result in contamination. The photo on the right shows an active dry cleaning facility, which may be associated with releases of chlorinated solvents. And it's important to note that some dry cleaner shops are actually dry drop-off locations where those chemicals are not handled by the site and may never have been handled at that site. So information is available on the FDEP website, on MapDirect, or on the handy-dandy contamination locator map. And those help to identify which dry cleaner sites have had active operations, usually actually using those chemicals. So it should be noted that the former use of a site can be very hard to determine, and it often depends on the accuracy of the regulatory database that's used for the Caesar study. On the left here is a church that is located at a former dry cleaners that had significant groundwater contamination due to chlorinated solvents. And then, of course, on the right here is the location of a former 7-Eleven gas station, but now it's a completely vacant lot, so it'd be a little hard to tell. Both were identified on the regulatory databases, though. The field reconnaissance may help identify problems that might impact construction, such as the need to remove underground storage tanks or abandon or replace existing monitoring wells. So on the left there, you see the UST removal, and then on the right, the image shows a monitoring well that's located within the right-of-way. The field review may also help identify where existing right-of-way may contain underground pipes. And if it's suspected that the pipes were relatively old, they might contain asbestos. We definitely don't allow those pipes to be crushed in place. The image there shows an asbestos transite pipe from an abandoned water line there. So the field review should also include observing evidence for petroleum storage systems, such as the underground storage tanks and above ground storage tanks, like I mentioned, the UST and ASTs, ventilation pipes, former dispenser islands, etc. Should also include observing existing and abandoned monitoring well sites and indications of existing or former remediation systems, such as trench-connected well vaults and equipment enclosure compounds, etc. The evidence of current and former land uses, as well as the information regarding above ground and underground utilities, should also be noted. Photographs should be taken of each site as well, and thorough notes. Bridge crossings should also be observed for their bridge number, estimated age, condition of surfaces, paint, concrete, etc. And the district structures engineer and district bridge engineer, maintenance engineer, facilities engineer, they may have additional information acquired during surveys or previous maintenance activities regarding the ACM and MBC on structures, bridges. A field review is performed to validate locations of facilities identified during the desktop review. Observe current conditions at locations where features of potential contamination were identified on aerial photographs, city directories, and Sanborn maps, and to identify indications of potential contamination that were not identified during the desktop review. So it's really important to get out in that field. Interviews, let's talk about interviews. So interviews with present and past owners, operators, and/or occupants of the properties with contamination concerns, and local government officials such as the fire department staff. Those may be used to verify or supplement the results of the desktop and field reviews as well. Interview resources typically include interviews with knowledgeable site owners or site occupants. Discussion may include recent and historical uses of the property and any involvement with regulatory agencies or the fire department. Interviews with regulatory agencies, especially the site manager for any FDEP sites. This would include getting the most recent FDEP site status information. And interviews with other local and government officials, such as the fire departments, like I mentioned, FDOT maintenance or right-of-way offices or permitting agencies. All right, let's talk about risk ratings. So we're going to go over no, low, medium, and high risk ratings. So as part of the Caesar or the level 1 investigation process, the FDOT uses the information developed in the desktop review, the field review, the interviews, etc., in conjunction with a review of the planned project construction activities to develop these ratings for each of these sites. So shown on this slide are the full definitions here of no and low. To summarize, the no rating for a site indicates there is no potential contamination impact on the property, and the low rating indicates that there is the potential for past uses of hazardous materials on the property, but there will likely not be any contamination impacts for the project. The next highest ranking here is medium. So shown on the slide here is the full definition of the medium rating. Basically, a medium rating is assigned when there is strong suspicion of potential contamination at the site, even though there may not be any direct sampling data yet to prove it. And as noted, it also applies to any active gas station due to its potential for future releases. So gas stations always get cited as medium. And of course, your high risk rating. For a high risk rating, after review of all available information and conceptual design plans, there is appropriate analytical data that shows contamination will substantially impact construction activities, have implications to right-of-way acquisition, or have other potential transfer of contamination-related liability to the FDOT. For sites with a medium or high risk rating, specific recommendations must be made regarding the soil or groundwater testing needed at the site, as well as a discussion of right-of-way considerations. The rating should consider proposed construction activities and determine if the scope of work may cause direct contact with the contamination. The risk ratings must also be seriously considered because medium and high rated sites will be evaluated further. A rating of medium or high should include a listing of the analytical parameters of concern and the media affected. And the ratings can actually change based on changes in the design, methods of construction activity, for example, driven piles versus drilled shafts. It can also change based on right-of-way needs and a whole bunch of other factors, so they can change. All right, another quiz. So head on back over to Mentimeter, and I'll get that pulled up. Go to our second question here, and then we'll find out who won. All right, here's our leaderboard here. So Siegfried and Roy is in the lead. All right, next question. Question 2 of 2. A medium-rated potential contamination site might include All right, nice job. Medium rated potential contamination site might include a gasoline station that remains active or has not been fully evaluated. Nice job. All right, let's see who won. All right, nice. Woo! The hustler hustled his way up to the top. Nice. Congrats to the hustler. All right, so let's finish up the presentation here. Go back to, all right, so we had our quiz. All right, so additional considerations regarding level 1 of investigations include a level 1 desktop review and site visits that may not be able to identify all contamination concerns. The level 1 is based on best available information. As such, unregistered tanks, unreported spills, and previous regulatory requirements may result in concerns not being identified. If unknown, these concerns or impacts are unlikely to be investigated during level 2 testing, unless, of course, it's found by luck, and thus may not be discovered or encountered until construction. The level 1 and level 2 investigations are conducted to help avoid construction contractor delays, claims, and costs due to contamination. These can add significantly to costs going over budget and cause schedule delays. No one likes that. So although impossible to identify every single concern on every project, it's really easy to see why careful evaluation is very important. You've got to utilize all your available tools and do your desktop review, go out to the field, have those conversations with people who are at those sites, and make sure that you have every rock unturned. All right, that's the end of lesson 4. So I will be passing it on over. Stop sharing my screen and pass it on over.
I'll take it, Christina, for the agenda.
All right, sounds good. That's right. We're going to go back to a break, aren't we?
We are.
Great.
All right, can you guys see the agenda?
Yep.
Okay, perfect. So I am going to bring up our timer as well. So folks, we're going to have a quick 5-minute break for you to stretch your legs, get a refresh of water or caffeine. And I know that we are running a little bit ahead of schedule, but I would think that we would want to leave a little early than try and stretch out our break. So let's go ahead and keep this break at 5 minutes and come back. Let's see, what time is it? 3:21 at around 3:26. So I'll just set this 5-minute timer and we'll be back with you guys when it goes off. All right, everybody, hopefully we're all getting back to our desks. All right. Our 5-minute break is up. Next, we have lesson 5, which is contamination in alternatives evaluation. So I will go ahead and stop sharing my screen and change the presenter over to Brad Bain. All right, Brad, should be all yours. You're on mute, Brad.
Can you see the screen?
Yes, but we see your PowerPoint, not
Right.
the presentation.
All right, how about that?
Yep, there we go.
All right. Well, this 5th lesson provides information on how to incorporate contamination issues into the alternatives evaluation process. This lesson will review some example PD&E studies to show how the potential alternatives were reviewed for their contamination involvement and how the alternatives compared to each other. During alternative roadway alignments are usually developed during the planning stage and become more refined during PD&E. New roadways can have several alignment alternatives with numerous segments or links that can be combined in various ways. Alternative alignments for existing roadways are often limited to center, left, or right alignments. Alternatives always include a no action alternative that normally has no contamination involvement associated with it. During a PD&E study, alternatives are evaluated, considered on their merits, reviewed for their impacts and cost estimated, and then some alternatives are eliminated. For projects that begin with multiple alignment alternatives, the alternatives are then reduced by eliminating ones that are impractical or have other issues. Alternatives are usually not eliminated solely due to the conflicts with contamination unless they encounter large contamination sites. The Caesars require that each potential contamination site is ranked no, low, medium, or high based on its proximity to the alignment alternative. It includes a table of the number of potentially contaminated sites per alternative. An example format of this table, as required in Part 2, Chapter 20, is provided here. Information from the Caesar is then used in other PD&E documents, such as the Preliminary Engineering Report, or PER. The alternatives matrix in the PER includes a table comparing impacts from contamination resource along with other resources. This is an example of an alternatives comparison table. This project, which just happened to be in District 3, had 4 primary roadway alignment alternatives in addition to the no action or no build alternative and the Transportation System Management and Operations TSM&O alternative. The no build and TSM&O alternatives did not involve ground disturbance such as excavation as part of the project. Therefore, they did not have any contamination sites associated with them, as the table shows. Alternatives 1 and 4 were the alternatives that were retained far enough into the PD&E study to be evaluated in the Caesar. I'm going to go over a couple of exercises that show some example Caesars and what was done to address the alternatives. This is the first of the 2 exercises intended to help PD&E project managers interpret contamination information as it relates to alternative evaluation. The first project example is the proposed Central Polk Parkway. which had a PD&E study done in 2011 and 2010. This project was planned as essentially all new roadway alignment divided into a western leg and an eastern leg. As far as I know, although I've lost track of exactly what's going on, portions of the western leg have design and construction funding, while the eastern leg has been transferred to Turnpike, and I am not sure of its status at the time. The western leg had 5 initial combinations of segments, also called links, with the preferred alignment shown here. Since during the PD&E study, the potential contamination sites were evaluated for each alternative, whether the alternative was preferred or recommended, or whether it was not preferred or not recommended. This slide shows 2 versions of the eastern side of the project. The eastern leg had 4 initial combinations of segments that were reduced to 2 preferred alternatives. The primary difference between the 2 preferred alternatives are the different locations of the proposed intersections within the E204 segment, which if you look at the T04 segment, you can see a couple differences where some intersections are. This page, which is from one table in the CSER, shows the number of potential contamination sites along the recommended segments or links, as well as those along those that were not recommended. The contamination evaluation along each link allowed for the determination of how many high, medium, low, and no rated sites were identified along each. This project passed through many current or former citrus grove properties. These properties typically had a medium rating unless there were indications from the field, such as fuel storage or pesticide storage, which warranted a high rating. This table, which is only the first page, summarizes the site number, type of contamination, site name and address, facility ID number, if any, the potential contamination source, distance from the proposed right-of-way, and risk rating for the preferred alternative. For this project, most medium and high rated sites were located adjacent to or within the proposed right-of-way. This table, which is only the first page, lists that same type of information as the previous table, but for those sites along the alignments that were eliminated from further consideration as preferred alignments. The list of sites associated with the eliminated links was retained in case a change in the preferred alignment is made later in the PD&E study. This paragraph here is the main summary of the whole findings of this CSER for the Central Parkway project. After evaluating and rating all the potential contamination sites for the entire project, including all the links that were recommended and those that were not recommended, the CSER identified 87 total sites. However, only 58 sites were relevant to the preferred alternatives. Therefore, the conclusions regarding project impacts were that 10 sites were rated high, 28 sites were rated medium, 18 sites were rated low, and 2 were rated no. This slide is going to show potential cost estimates. These estimates can be helpful in just giving a general idea of the costs of contamination assessment and remediation as compared to, say, some other types of costs for the projects. And these also may be helpful to the DCIC when they go to get funding for the project. It is usually helpful to the DCIC and district personnel for the CSER to provide cost estimates for assessment and cleanup of the medium and high rate of potential contamination sites identified for the preferred alternative, generally not the ones that aren't preferred. However, Part 2, Chapter 20 does not require detailed cost estimates. The cost estimates can be based on experience with similar projects and they will include certain assumptions about how much soil and/or groundwater needs to be cleaned up at each site. Then I'm going to go over the considerations regarding contamination for PD&E studies and alignments. As we saw from the previous exercise, the CSER is used to determine how many sites are ranked medium, low, no, and high along the project alternatives. This information can be used to develop cost estimates for contamination assessment associated with those sites. The information in CSER is carried into the other aspects of the PD&E study so that the number of medium and high rated sites can be compared with the other resources and costs impacted by the project. So now I'm going to go into the next exercise, which discusses a different project. This exercise provides an example of a comparison of resource costs and issues for a large bridge replacement project in Manatee County. Early in the PD&E study, a preliminary alternatives comparison matrix was developed. There were several alternatives developed for this bridge along both northern and southern alignments, in addition to the no build and a bridge rehabilitation alternative. The build alternatives included 2 bascule bridge alternatives for the southern and northern alignments. At this point, prior to review by the district, only 1 medium ranked site had been identified on the project. This particular project went through several reviews, and so the number of contamination sites changed. During the draft CSER study, 7 potential contamination sites were identified along the project. At first, only 3 sites were ranked medium and none were rated high. However, after the district reviewed the CSER, the district requested that 2 additional sites be ranked medium due to the potential for those sites to have further involvement with dewatering operations. The dewatering operations must consider sites within a 500-foot radius for permitting purposes. This table lists the number of potential contamination sites and their ratings, along with the same type of information provided in the table for the Central Polk Parkway in the previous exercise. This table was finalized after district review and agreement regarding the 5 medium rated sites. In this case, all of the sites have facility ID numbers due to their involvement either with the EPA or FDEP. After review by the district, the CSER evaluation determined that there were 5 medium rated sites and 2 low rated related sites. This information was carried forward to assist with estimated costs for comparison to other resources. This table from that same project provides very rough cost estimates for contamination cleanup for the medium rated sites identified in the CSER. The table is similar to the cost estimate table provided in the example exercise for the Central Polk Parkway. Since these sites were all rated medium, not high, and the exact amount of contamination at each site is not yet known, the assumptions used to calculate the costs were similar. As will be seen, these costs are relatively low compared to right-of-way costs and construction costs. This is a type of alternatives comparison table or matrix that is included in the PER. As this particular project continued through the PD&E review process, which required 2 revisions to the CSER, the analysis of the alternatives narrowed down to the alternatives for 2 proposed alternatives that would be carried forward, along with the no-build alternative, which was a short-term repair of the bridge. The recommended alternatives were those determined by the district and OEM as being feasible for moving forward for public involvement and consideration. As noted on this table, all 5 medium-rated sites are listed for both of the northern alignment alternatives. As you can see, the differentiating factors for the build alternatives include the amount of right-of-way needed, affected parcels, and the number of potential noise sites. Since the contamination impacts are the same, which is just those 5 medium rated sites, they are not a critical decision-making factor when evaluating those alternatives. This slide shows the bottom of that same table, which addresses the utility impacts and estimated capital costs of the alternatives. It should be noted that the build alternatives have a 75-year lifespan, while the no-build repair alternative is just 10 years. The costs were dominated by bridge construction, roadway construction, right-of-way, and design. Any potential costs related to the cleanup of contamination sites would be small by comparison to these other costs. For the 75-year lifespan, the fixed bridge with the northern alignment has the lower overall estimated cost. And now we're to the quiz question. So Christina can take it over from here.
All right, let's go to some quizzes. All right, menti.com, and enter that code in the top of the screen there. Give a couple more seconds there. All right, let's go ahead and get started. Roadway alternative alignments are frequently changed solely due to contamination impacts. True or false? All right, false. Nice job, everyone. All right, let's see here. And next. There it goes. Question 2 of 2. Review of the Caesar is focused on identifying which types of sites. A and B above. Good job. Nice job, you guys. All right, let's see who won. There it goes. All right. Nice job. All right, and there's the second question. There we go. Tiger Baby, 1958. Nice. All right, I'm going to pass it back to you, Brad.
All right.
All right. Okay, there we go. Back to you.
And you can see my screen now?
Yep.
All right. So yeah, we went over the questions, and the answer for the first one is false. And the answer for the second one was A and B above. So to summarize, the evaluation of contamination impacts as they relate to the analysis of alternative roadway alignments, these are the main things to keep in mind. The Caesar identifies the number of potential contamination sites along each roadway alternative alignment analyzed during PD&E and determines the number of sites rated medium, high, low, or no. The medium and high rated sites are usually given priority as the PD&E studies move forward. The number of medium and high rated sites are usually included in the alternatives analysis matrix of the PER. Costs associated with contamination cleanup are usually relatively low compared to the costs associated with other project features. The alternatives analysis usually considers other resources costs and costs such as public preference, right-of-way, construction costs, noise-sensitive sites, wetland features, and other factors as determining factors in the analysis matrix. Once the alternatives are evaluated, the preferred alternative is selected and the project is approved for design, there are some additional considerations. The project's plan and potential schedule should be discussed thoroughly with the DCIC because contamination-related information is a moving target and may change drastically over time. The DCIC is assisted in his or her efforts when provided factors such as likely production and letting dates, right-of-way needs and schedule, potential for advancement in schedule, and potential to become design build. That essentially summarizes going into the next step of the process. Oops. Thank you. I'm done.
Thank you, Brad. All right, so next up we have lesson 6 for Mike Gonzalez. And I will change the presenter over to Mike now. And Brad, you're welcome to turn off your camera and your mic, and we'll flip it over to Mike and Laura. Mike, I'm seeing your screen, but not hearing you yet.
Okay, you should hear me.
There. Yep, there we go.
Okay. All right, we're in the home stretch now. This is lesson 6. This is contamination review for reevaluations. There's some typical steps in the contamination review process for reevaluation. Those are all covered in part 1, chapter 13 of the PD&E Manual. You should be looking at any design changes from the accepted PD&E concept that should be reviewed. And in addition to that, you want to look at any condition changes, especially projects that have been shelved for a long period of time. Should be looking at the desktop Caesar that would have been done previously. And you want to look at some of the other information. If there's been a level 2, you want to look at that as well, just trying to make sure that what has been done covers the new design or the revised design. And again, look at the level 2. We'll talk a little bit about the level 2, what items need to do for the reevaluation in the following slides. So we have some primary purposes for this level 2 assessment. One of the first one is to determine if the design is going to impact any of the identified contamination sites. You're going to look to see if the construction activities that are planned would exacerbate the contamination, especially when you're looking at impacts to groundwater flow direction by pond sites. Those can impact groundwater flow direction quite a bit. And after LDCA, really all of the medium and high rated sites should have been assessed to determine if there is contamination or to determine that it's not there. And as mentioned before, the level 2 assessments are really only done for projects in the 5-year work program. So if something's been shelved for a long time and gets brought back into the work program, it may need to be updated. When you're looking at the level 2s, as we said before, are done on medium and high rated sites that are identified during PD&E. There's some typical things that are involved. They typically involve field work, typically involve the soil and groundwater sampling, both in some cases. And the level 2 should be talking about remediation if it's needed and cost estimate if they can provide it. And should be looking at recommendations for avoidance, for minimization of worker exposure, and remediation, usually prior to construction, should also be provided. When we look at some typical methods for performing level 2, we've got the soil boring to collect the soil samples. These can be done by hand auger or direct push rigs, drill rigs. You're looking at installing temporary monitor wells for groundwater samples. Again, those can be hand installed or by direct push rigs or drill rigs. You'd be looking at doing geophysical surveys, usually electromagnetic or ground penetrating radar surveys, if you believe that there's buried waste, solid waste, or USTs, especially if the limits of the project or the right-of-way take of the project has increased. And also USTs. Test pits, if you believe that there's solid waste or debris buried on the project, you should be doing test pits. Screening soils with the organic vapor analyzer, also called an OVA. This is really done for petroleum vapors. And obviously, if there's additional ACM or metal-based coating surveys that need to be done, that should be done here. When we look at some generic examples of what a typical level 2 investigation looks like, we would be doing soil borings and monitor wells in the existing proposed right-of-way in front of the medium and high-rated sites. That would really be predicated on any areas that require excavation or dewatering. Those are ones you really want to look at closely. The soil borings and temporary monitor wells at the pond sites and FBC sites should be done. Temporary monitor wells for the NPDES discharge permits, that should also be done, hopefully prior to construction. That is really something that can cause the project to really get tripped up if the contractor goes out and does his NPDES permit sampling and then determines that there's a problem. That's not the time you want to learn that there's a problem. The soil borings and test pits, as we mentioned earlier, to determine the presence of the solid waste and debris. Also, if you have USTs or underground storage tanks or above ground storage tanks on the project, you usually have to require a closure assessment, so you could do soil and groundwater sampling for that. And ACM and metal-based coating surveys on the bridges. And asbestos is normally found, as we kind of went over, with scuppers, joint mastic, the class 5 coatings, bearing pads, but also in concrete. And the timing of the scope is kind of important. So level 2 assessments are usually done at design, preferably prior to the end of the right-of-way phase or phase 4 plans at the latest. It should be done for the medium and high rated sites and should be looking at the full take, partial take, or widening projects. You want to evaluate the primary and the alternative pond sites for both the SMF and the FPC. Sometimes ponds will move through the project and you don't want to have to try to do an assessment later in the project. You want to evaluate the design changes that may occur. One of the things that is really kind of an important thing is these UWHCAs, the utility work by highway contractor agreements. This is work that would be done for a third party within the DOT right-of-way by the contractor. So a lot of times it won't show up in the plan set until very late. Revised pond locations, I talked about it. One of those things that you'll always run into is that the original pond site that you're looking for has been taken, or the seller does not want to sell it. So you're going to have to look at a revised pond location where it doesn't work for your design. And construction or excavation that's added to simple projects, such as a resurfacing project. A mast arm, a cross drain, any other drainage features that are added to that project could then impact contamination, so you would want to look at those sites as well. For the ICA, or the Impact of Construction Assessment Level 2, there really are several things you should be looking at in that report. First one is an introduction. You want to know what the project is about. You want to have a summary of the methodology, how they went about their assessment, what they did to do that assessment. You want to have some results. You want to know what the results of the soil and groundwater samples are. Normally, you want to separate that up and make sure those are in tables, and we'll talk about that a little bit later. Conclusions and recommendations. We need to know what their conclusions are in the report and what their recommendations are for either further assessment or remediation. And there should be appendices. This really should be anything that would have been collected as part of the assessment, the soil boring logs, the groundwater sampling, any of the laboratory analysis, and anything else that was done, including the mineral base coatings or ECM survey reports. When we look at the sampling activities, the report really should show information for each site that's along or adjacent to the project corridor, especially if you have a project that the pond site is not located adjacent to the corridor, but off slightly. The soil OVA readings should be provided in a table, and we'll see that later. And the soil lab results should also be provided in a table, and they should be compared to the soil cleanup target levels. Groundwater lab results should also be in a table, and those should be compared to the groundwater cleanup target levels, or GCTLs. And maps or plan sheets should be provided that identify the estimated area of contamination and locations of potential groundwater flows. And as I said earlier, one of the things you want to have is any ACM reports, geophysical surveys, test pits, any of that stuff would either be in the level 2 that was submitted or in a report that has a similar format. So we'll look at some items for report conclusions and recommendations. So the recommendations should be provided in table format so they're easy to follow. And they should provide specific recommendations for each site. The recommendations for the remediation, which is the level 3, should really include the type of remediation that they're going to do. What is the cleanup going to require? If there's reuse or disposal of the soil, especially stuff that exceeds the soil cleanup target levels, that really should be identified as well in that. Or if you're going to keep soil on the site. For groundwater treatment, you want a recommendation for the type of groundwater treatment, maybe even information about what they're planning to do, and also whether they're going to be discharging to the surface water body or another facility. If it's available or if it's possible, a cost estimate should be provided for the remedial activities, or if there's any additional investigations that are needed. And the level 3 or level 2 assessments and the ICA should be provided to the construction contractor. Normally at the time of project bid, that's not always possible. If possible, then it would be at award. And if not possible, we really should have it by the pre-construction meeting. And the report should be posted on the DOT website or in SWEPT. Not going to go too much into detail on this table. It's a little bit hard to read, but one of the things that we wanted to look at, this is just a summary of the table. On the left, we have the study area, we have the proposed construction, we have the information on what they did at that location. Also next to it is some information related to what they found at that location. Refers you to some tables and some figures. Then it refers you to what the depth of groundwater is. That's kind of important if there are changes to the design, especially for the drainage structures. And then at the far right is the information related to the recommendations for remediation. For this soil analytical table, we've seen a little bit of this before. On the left-hand side would be the compounds or constituents that they're concerned about. In the middle would be the information for each one of the soil borings that were done, and the information on each one of those compounds should be underneath that soil boring. And then on the right-hand side, in this case, would be the soil cleanup target levels. You'd be looking at residential, commercial, industrial, and leachability. In some cases, leachability will be the driver, but in other cases, it will be the residential. On the groundwater analytical side, it's really looking the same. You have the compounds on the left, the boring locations or the groundwater samples in the middle, and those should be compared to all of the different compounds. And then on the right-hand side should be the groundwater cleanup target levels from 62,777. This one's a little bit hard to read, but in this case, what you want to look at is that this figure is showing all of the assessment that was done. Yellow indicates an exceedance. And then the figure actually has on there the extent of soil contamination in the red hatched area and groundwater contamination in the green circle. When you're looking at just groundwater impacts, you have the results again showing all the results that were done in that area and the groundwater impact in the hatched circle. This is really driven by the fact that there's a cross drain system right there. If there's no cross drain, or if there's no drainage system and there's no chance for dewatering and groundwater contamination may not be that much of an issue. So we've got a couple of quiz items, and I think we're going to turn it over to Mentimeter.
All right. All right, question 1 of 2 here. So we're going to go through both of these questions and then we'll see who wins. A couple more seconds here. All right, we'll go ahead and get started. Level 2 assessments are typically performed during the design phase. True or false? True. Nice job. All right, let's move on to the next question. Question 2 of 2. Level 2 assessments may include E, all of the above. Nice. All right, ready to see who won? John, nice job. Congratulations, John. All right, and I think that's it for our Mentimeter quiz questions for today. I'm gonna pass it back on over.
Okay, can you hear me all? Can you all hear me?
Yep, and we can see your screen too.
All right, excellent. All right, so obviously, the first one is true. And all of the above. That's doing a good job. So to wrap things up, if you have questions about this training or any contamination issues, you can talk to Mike Pennington and DOT Central Office. His email and his information is here. I'm going to leave it up for just a second so y'all can see it. And I'll move on. So anyone who is in learning curve, DOT staff or consultants, this is the information for setting that up so that you can get credit for this training.
Yeah, say this is Mike Pennington. Just to expand on that, this is kind of a new thing that we're doing, that you have to go in yourself to Open Learning Curve and enroll to get your PDH hours, and this class will give you 3 PDHs. And I'd like to thank all the presenters for presenting today, and everybody who logged in and listened here. So thank you, everybody.
Well, we finished up a little bit early based on our agenda. So Mike, thank you for having us, and thank you, team, for all of your help with the presentation. And links to all the documents that were referenced in the presentation in the question box.
Oh, okay. Yes, I think we're gonna post the webinar on our website, and I don't know about the actual copies of the. I can send, if anybody needs a copy, just email me, and I will send you a copy of the PowerPoints. Does that answer that, Lauren?
I believe so. I'm not exactly sure which documents Diane Waters was referencing, but I think that might cover it.
Okay.
Diane, if you need a follow-up to that, just let us know.
Yeah.
Yes, absolutely.
Oh,
Frank,
yeah.
you're welcome to ask questions. Mike Gonzalez, can you pop up that last slide for learning curve, please? Thank you. Jose, that should answer your question on the PE credits.
Yeah, you might want to see if you can screenshot this. It's hard to kind of see here. There's like a little search here.
Mike Pennington, what
on...
about the folks that don't have learning curve access? Do we still get a certificate?
Oh, I'm not sure. I don't know.
All
I'll have
right.
to get back to you on that.
Okay. All right. Christina and Brad and Mike Gonzalez and Mike Pennington. There's a question in the chat box about in the manual, the distance for brownfields is not explicit, but it is mentioned in this webinar. I think it was in Christina's webinar. Can you expand on that?
It was in my webinar, you're right. That might be more of a question for Brad to answer, though.
To be honest, I would actually have to go in and look at part 2, chapter 20 to figure that out. I believe brownfields could either be 1,000 feet or a half a mile, but I'd have to check the actual section of part 20.
I think in the
20.
presentation it was a half a mile, but it would probably be worth double checking.
It never hurts to go out a little farther, and if it's not relevant, then just don't look into it further.
Diane, to go back to your question about the documents referenced, like the FDAT PD&E Manual, that is available on the OEM website, and links to the Florida Administrative Code and things like that should be available by Google. Jose, the question about the learning curve. If you don't have access to learning curve, we're going to follow up on how to make sure that we get PDH credits, even if we aren't registered in learning curve. Can we describe the difference between a Caesar and a tech memo? Brad, you want to take that one?
Yeah, Caesar, if you go into part 2, chapter 20, it's got quite a few chapters, including the geology of the area, all the land use in the area, all the alternatives, et cetera, et cetera. A tech memorandum basically just focuses on, hey, we looked at these areas, these are the number of sites we found, and these are the ratings. It doesn't necessarily have to provide all that other background information, which can be time consuming to get that put together.
Any other questions from the audience? Right, I hope we answered everyone's questions. If not, Mike Gonzalez, if you want to go back one screen to Mike Pennington's contact info, we can, you can feel free to reach out to him. Mike, I'm throwing you out there. Contacting for any other questions.
Yeah, feel free to contact me and yeah. If you can't figure out the learning curve, let me know and I'll see what I can do. If you have a learning curve, I just did it myself. I went in there, I searched contamination. It was the first one that popped up called Contamination Workshop Training and enrolled, and it was pretty simple. So.
All right, well, thank you, everybody.